Imagine a head teacher at a busy secondary school trying to calculate the final term grades, average scores, and class positions for 200 students. If they use only a piece of paper and a pocket calculator, this task takes days of continuous arithmetic. If the head teacher discovers that a single teacher submitted the wrong math scores, the manual ledger fails. Because every total is linked, they have to erase their work and recalculate everything from scratch. This is why we use a spreadsheet. A spreadsheet is a digital ledger, a giant grid of numbers and text that acts as a supercalculator. By moving data off paper and onto this digital grid, we transform data management from a slow, manual chore into an automated system. When you open a spreadsheet application like Excel, the workspace looks like a large piece of graph paper. It functions as a digital coordinate system. Vertical sections are columns, labeled with letters A, B, and C, like tall concrete pillars. Horizontal sections are rows, labeled with numbers, like flat roads across a landscape. The box where they intersect is a cell, identified by its coordinates, like this cell B3. Mastering this coordinate map is the necessary first step to using the computer's computational intelligence. This spreadsheet shows a tuck shop inventory. Column A lists items, pasho, beans, sugar, and column B lists prices, in B1, B2, and B3. If we type sum B1 to B3 into cell B4, nothing happens. The computer treats this as a normal word, not a command. Every formula must begin with an equal sign to trigger a calculation. Without it, the software just sees a label. Adding the equal sign transforms it into a functional formula. Notice the syntax. Parentheses hold the data, and a colon includes the entire range. The equal sign is the essential trigger that activates the spreadsheet's internal calculator. If the price of pasho in cell B1 increases from 5,000 to 8,000, we simply update that cell. Because the formula in B4 points to location B1 instead of a static number, the total instantly updates to 18,000 automatically. This is the power of cell referencing. If you type raw numbers into a formula, the math stays frozen. But by referencing the grid locations, you create a dynamic ledger that responds to every change in the data. Calculating by grid location is the secret to creating self-updating, accurate records. This dynamic calculation works the same way for much larger datasets, such as biology exam scores for an entire class. Sorting the data in descending order instantly organizes this list from highest to lowest, placing the top-performing student in the first row. To analyze these scores, we use built-in functions like max, min, and average. These follow the same syntax we used for our sum: an equal sign, the function name, and then the cell range inside parentheses. Let's try it. If student ages span from cell C2 to C30, write the exact function to find the youngest age. You have 5 seconds. The correct formula is equals min, then the range C2:C30 inside parentheses. These functions act as prepackaged math tools, allowing you to execute complex statistical analysis in seconds. Large grids of numbers can be difficult to interpret quickly. We use charts to turn those numbers into visual insights. To visualize our tuck shop inventory, we highlight the data, open the Insert menu, and select a pie chart. This chart shows the proportion of sales for each item. By looking at the slices, it's clear samosas are the most popular shop item. Other tools like bar charts help compare different amounts side by side, while line charts are used to track how values change over time. Charts are the final step in data management, translating mathematics into a format that is easy for any audience to understand. To summarize, spreadsheets are organized into vertical columns and horizontal rows. Every calculation must begin with an equal sign, telling the software to perform math. By using functions like sum, average, max, and min, you can process large amounts of information with high accuracy. By mastering these digital tools, you can automate calculations and analyze data for an entire school, business, or national exam system.